All right, guys, so what we're doing today is solving rational equations. We're going to go through this note sheet here. So this one here is the first one we're going to look at, and it's good to first look and make sure that the denominators are factored, and then find restrictions and go from there. And looking at the two denominators, well, the only one that we have with the variable is 3x minus 1, and they are both factored. So we can first look at our restrictions. So we take the denominators where we can plug a variable or a number in for x. Ones that have variables, we set them equal to 0. And then solve. Just find our restrictions. So the first thing we can do is add 1. Then we would divide by 3, telling us that x cannot be positive 1/3. Because if we get a solution of positive 1/3, it's one of our restrictions and it doesn't work. Now the next thing we can do is actually start solving. And when we solve them, we're going to multiply each part of the equation by an expression to get the denominators to simplify. Well, one thing we know we can multiply both sides by is 3x minus 1. Because here, the 3x minus 1 and 3x minus 1 will cancel. Are all the denominators simplified? No, we also need to multiply both sides by what? 4. Because here the 4 and 4 will cancel. Now all the denominators have been simplified, and we can put what we have left. So on the left-hand side, we have 6 times 4, which is 24. On the the other side, we have 3 times 3x minus 1. So we had 6 times 4, which was 24. And on the other side, we had 3 times 3x minus 1. At this point here, we can start simplifying. We can multiply through by 3. 3 times 3x is going to be 9x. 3 times negative 1 is negative 3. Now, since the only variable we have is x, and it's only to the first power, we just need to get it by itself. So here we can add 3 to both sides, telling us that 9x is equal to 27. And lastly, we would divide both sides by 9. And 3 is not one of our restrictions. That's it. Yeah. Questions on this here? Be ready for the next one. Here, both denominators are already simplified. We don't have to factor. We have x and x minus 4. So since we don't have to factor, we can go on and find the restrictions. Well, for just x, well, x cannot be 0. Here we can add 4 to both sides, telling us x cannot be 4. So if we get a value of 0 or 4, those are our restrictions and they don't work. Now with solving, what do we need to multiply everything by? Yes. X and x minus 4. Because here the x and x will cancel, leaving us with 5 times x minus 4 is equal. X minus 4 cancel, leaving us with just 7x. Here we can distribute the 5. 5 times x is 5 times negative 4 is negative. What would we do next? Right, we would minus the 5x from both sides, telling us that 2x is equal to negative 20. Lastly, divide by 2. Telling us x is negative 10. Any questions on these here? So for this one here, we can find restrictions. And our restrictions are just whatever values are going to make the two denominators be 0. So for this one here, what would our two restrictions be? Negative 1 and negative 7. Because negative 1 plus 1 is 0. Negative 7 plus 7 is 0. So those two values we can't have. Now we want to multiply both sides by x plus 1 and x plus 7. On the left-hand side, the x plus 1 and x plus 1 would cancel. On the right-hand side, the x plus 7 and x plus 7 would cancel, leaving us with x plus 3 times x plus 7 is equal to 15 times x plus 1. Now for this one here, we do need to distribute. X times x would give us x squared. X times 7 would be plus 7x. We do the same thing with 3. 3 times x would be plus 3x. And 3 times 7 would be plus 21. Is equal to, here we can distribute the 15. Combine like terms, 7x plus 3x is 10x. What can we do next? Yes, we minus 15x. Which will tell us we have x squared minus 5x plus 21 is equal to 15. We'll need to minus 15. Notice that we have x squared minus 5x plus 6 is equal to 0. Because again, since we have a quadratic, we have a variable with a power greater than 1, we need to get everything on one side and set it equal to 0. Now at this point, we can factor. Since there's not a greatest common factor to factor out, we can just do our two sets of parentheses. Since the third term is positive, our signs are the same and match the sign of the middle term, which is negative, so negative and negative. Factors of x squared are, and factors of 6 that we want are 2 and 3. Well, at this point, we would set them both equal to 0. Solve would tell us x is equal to 2. Or either one of these are restrictions. Nope. So both of those work. Now we could have also graphed it. We could have said x squared minus 5x plus 6 and hit graph. We see that it does cross the x-axis at two places. If we go second graph, we see that those two values are 2 and 3, which we did find by factoring. So we could have graphed it and got the answers as well. Any questions on any of this here? Are you ready for the next one? So here, if we found the restrictions, well, here we would subtract 2, telling us that negative x is equal to negative 2, or really that x is equal to 2, because 2 minus 2 is 0, so x cannot be 2. And for the other one, we would minus 7, telling us x cannot be negative 7. So we can't have positive 2 or negative 7. What would we need to do next? By 2 minus x and x plus 7 or 7 plus x, either one works. Because the x plus 7 and x plus 7 or 7 plus x would cancel out. On the other side, the 2 minus x will cancel out with the 2 minus x, leaving us with 12 times 7 plus x is equal to 15 times 2 minus x. And the first one here, we can distribute the 12. 12 times 7 is 94. No, 84. 84. 12 times x is 12x. Here we can distribute the 15. 15 times 2 is 30. And 15 times negative x is negative 15x. Now again, since x is to the first power, we just need to get x by itself. So what can we do first? Yeah, we could add 15x. We could have subtracted 12x. We could have subtracted 30 or subtracted 84 from both sides. Any one of those would work. We just need to pick one to do first. And what that'll tell us is 84 plus 27x is equal to 30. Now again, we still need to get x by itself, so we would need to subtract 84 this time, telling us that 27x is equal to negative 54. And last but not least, we would divide both sides by 27, telling us x is equal to negative 2. Any questions on any of this here? We feel good with all these here. All right. Let's look at this one here. So this time they're not both set equal to each other. We have 3 expressions. And again, all the expressions are factored, so we can kind of find the restrictions. Now, what would the restrictions be? Positive 4 and 3. Because the equals 1 doesn't have any impact on it. It's just that's what it equals. So just 4 and 3 would be our 2 restrictions. Now at this point, we're going to multiply everything by y minus 4 and and in the far left one, the y minus 4 and y minus 4 will cancel. The middle, the y minus 3 and y minus 3 will cancel, and nothing cancels with the 1. So what we're left with is 4 times y minus 3. Minus 3 times y minus 4 is equal to 1 times y minus 3 times y minus 4. Questions on this here? Now I'll need to distribute this here. We'll distribute the 4. 4 times y is 4y. 4 times negative 3 is negative 12. We'll distribute the negative 3. Negative 3 times y is negative 3y. Negative 3 times negative 4 is going to be plus 12 is equal to, here we can do the same thing, we can distribute. Y times y is y squared. Y times negative 4 is negative 4y. Negative 3 times y is negative 3y. And negative 3 times negative 4 is plus 12. Now at this point here, we combine like terms. 4y minus 3y is 1y. Negative 12 plus 12 is 0. These are gone. Equals, well, we still have y squared. Negative 4y minus 3y is negative plus 12. Now, since we have a y squared, we have a variable squared, we're going to need to get this equal to 0. So we'll need to subtract y from both sides, showing us 0 is equal to y squared minus 7y plus 12. Not 7y. 8. Because negative 7y minus y would be negative 8y. Now, on the last one, we went with factoring first. We can try graphing this one first this time. But instead of saying y, we're going to say x, because anytime we plug it in, no matter what the variable is, we use x when graphing. And we do get it to cross at two places. And those two places are 2 and 6. Those are the values of x that make y be 0. So y is equal to 2, and y is equal to 6. Our two solutions are either one of these are restrictions. Nope. But that's it. Questions on any of this here? We're ready for the next one. Now looking at this one here, are all the denominators factored or simplified? So the x plus 1 is the x squared plus x does have a greatest common factor of x. And we need to factor it out. Because if we do, we get x times x plus 1. So that is helpful because we don't need to multiply everything by x plus 1x and x squared plus x. We only need the x and x plus 1. Now for our restrictions, we know one of them is going to be 0. Because anytime we have a variable by itself, 0 is going to be a restriction. And negative 1. Because our x plus 1, negative 1 plus 1 would be 0. So that means we can multiply everything by x and now we only need x once because in any of the denominators it only shows up once. And x plus 1 only shows up in any of the denominators once. Shows up in more than one fractions denominator, but in each one it only shows up once. So in our first one, the x plus 1 and x plus 1 cancels. In the middle one, everything simplifies. In the last one, our x and x. So what that leaves us with in the first one is 2 times x, which is minus equals. Yes. And if we multiplied it through, we would get that 2x minus 1 is equal to 3x plus 3. Now what do we need to do? What else are we going to eventually end up doing? Yeah, subtract the 3. Which will tell us x is negative 4. Is that our one of our restrictions? No. So that's it. Probably not. Spot it. Questions on any of these here? So this here, we have two denominators that will factor. One of them is the 5x plus x. How can we factor this? Factor out the 5. Which gives us 5 times, 5x plus 5 when we factor the 5 out. 5x becomes x, 5 becomes 1, and we have 5 times x plus 1. Now the x squared plus 3x plus 2, there's not a greatest common factor, but we can factor with 2 sets of parentheses. Since the third term's positive, the signs are the same and match the sign of the middle term, plus and plus. And that does work out nicely because we don't have any extra factors added to it because of it factoring. Now what are our restrictions going to be? So where can it be 0? Well, x plus 1 and x cannot be negative 1. And here x cannot be negative 2. Yeah, because I can't plug a value in and make the 5 be negative. Because we're only looking at what values of x will make it be 0, and the 5 doesn't have an impact on it. So what do we need to multiply everything by? Now on the far right, the x plus 1 will cancel out with the x plus 1. X plus 2 will cancel out with the x plus 2. The one in the middle, the x plus 2, will cancel out with the x plus 2. And the one on the far left, the x plus 1 and x plus 1 will cancel. Yes? Are all the denominators simplified? All right, we got to multiply everything by 5 as well. So the 5 does not include or is not a part of our restrictions, but is something we need to multiply everything by. So x times 5 times x plus 1 plus 5 times 1, which is 5. Yeah, on the far one on the left, we have the x from the numerator and x plus 2 that we multiplied it by still left. The middle one, we do have the 5 and x plus 1 being multiplied by 1, which doesn't really impact anything. And the last one, everything but the 5 canceled out, so we have 1 times 5. Now at this point here, we can distribute. X times x is x squared. X times 2 is plus. Five plus 5 is. Now we just need to get this equal to. So we subtract 5x from both sides. Telling us that we have x squared minus 3x is equal to 10. At this point here, we can 10 from both sides. Notice that we have x squared minus 3x minus 10 is 0. Do we want to factor it or graph it? So we have x squared minus 3x minus 10. Graph. We do have 2 places it crosses. Negative 2 and 5. So it tells us our 2 solutions, that is x is equal to negative 2 and x is equal to 5. Negative 2 is one of our restrictions, so our only real solution is x is equal to 5. So really the process of doing these when we have a restriction and when we don't doesn't really change. It's just at the end we have to take out any of the restrictions. Any questions on any of those here? Let's do this one here. This will be the last one that we do. Well, looking at this here, the x minus 2 is factored. The x plus 2 is already factored. But we can factor the x squared minus 4. X squared minus 4 is a difference of perfect squares. So we get x plus 2 and x minus 2. Now, what would our restrictions be? Because negative 2 will make x plus 2 be 0. Positive 2 will make x minus 2 be 0. So those are our 2 restrictions. And we need to multiply everything by. X minus 2 and x plus 2. The one on the far left, the x minus 2 and x minus 2 will cancel. The one in the middle, the x plus 2 and x plus 2 will cancel. And the one on the far right, everything will simplify out, leaving us with 5 times x plus 2 minus 2 times x minus 2 is equal to 3. Negative 2 times negative 2, positive 4. So we multiply through and we get 5x plus 10 minus 2x plus 4 equals 3. Combine like terms. 5x minus 2x is plus 14 is equal to 3. So is x already by itself? 14, yeah. Yeah, we need to subtract 14 from both sides because we do, I think the question I was actually going to ask, is x already on one side? Well, yes. So minus 14 telling us 3x is equal to negative 11. Then we divide by 3, telling us x is equal to negative 11 thirds. And since it's not one of our restrictions, that's it. Questions on any of this here? All right.